All right, I've got two more rules for differentiation here for you. Again, I'm not going to go through the proofs. What I am going to do is give you the rule, show you a quick example. The first is product rule. I've got two functions, u and v. So we'll just say that our function is equal to u times v, the product of. And I want to know the derivative of that product. Well, the rule is u dv dx plus v du dx. It's just one function times the derivative of the other plus the other function times the derivative of the one. So my example will be that y is equal to x squared plus 1, x cubed plus 3. Now, I'm going to recommend immediately that you be very, very organized, that you start by defining u equal to v equal to. Next to those, you write the derivative of u and you write the derivative of v. If you try to do this in your head, unless you are very, very good, you are probably going to mess up. So what is the derivative of y? Well, u times the derivative of v, so we've got 3x times x squared plus 1, plus v times the derivative of u. We've got 2x times x cubed plus 1. And if we wanted to do a little simplification, we certainly could. We would get 5x to the fourth plus 3x squared plus 6x. Good idea to be in the habit of doing simplification, except on the AP test. Don't do any simplification unless you have to. So for my students, why don't you go ahead and do exercise 13 out of the book. You can pause the video here. And when you come back, we will talk about the quotient rule. Welcome back. Here we are talking about the quotient rule. And the idea here is that y is equal to u divided by v, where u and v are functions of x. And the quotient rule says that the derivative of y is. Now, a little more complicated, you're going to have to memorize this. This quotient function multiplied by the derivative of the numerator there, minus the numerator times the derivative of the quotient, the denominator, all divided by the denominator squared. Again, there's a proof. It's complicated. You don't really need to know it. It helps, if you don't believe, but we'll let you look that up on your own. So let's do a quick example. We're going to define our function as y equals x squared minus 1 over x squared plus 1. Again, define your variables. U equals x squared minus 1, v equals x squared plus 1. If you don't define your variables, you are going to mess this up. U prime, the derivative of u with respect to x is 2x. The derivative of v with respect to x is 2x, which means that the derivative of y with respect to x is, here we go, v x squared plus 1. Derivative of u, 2x, minus u, x squared minus 1. Dv, derivative of v, times 2x, divided by v squared, that x squared plus 1, all squared. If we want to simplify this, we get 4x over x squared plus 1, all squared. Okay, go ahead, my students, go ahead and do exercise 19 in the book, and you can pause this video. And let's do another example, example 3, which is what if I have numeric values? And this is sort of a data issue. Sometimes you just collect data and you've got data. So what if I know that one function at x equals 2 has a value of 3, but it is changing at a rate of -4? And I have another function at x equals 2 with a value of 1, and it is changing with a rate of +2. And I've got some function that is the product of both of these. Well, all I do, I know that's u dv plus v du. I plug in the numbers. U is 3, dv is 2, v is 1, and of course, sorry, I want to find the derivative at x equals 2, and the rate of change of u is -4, and this is equal to 2. This function at x equals 2 is changing with a rate of 2. So go ahead and do exercise 23 for those of you in my class, and we'll see you back in the next video. Thanks for watching.